Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I'll be discussing about Chemical Kinetics chapter, which is the fourth physical chemistry chapter from standard 12th. So we'll be discussing some important concepts from that chapter and also the formula which are important in exam point of view. Okay, so let us start. Chemical kinetics. Now, what is chemical kinetics? Okay, so chemical kinetics is a branch of chemistry which deals with the study of reaction rates and their mechanism. Now, we know that reaction takes place, then products are getting formed, but at what rate reaction takes place, okay, and what is a mechanism for that? So, that is explained by this branch of chemistry, which is chemical kinetics. Okay, so let us start with the rate of a chemical reaction. Now, what is rate? Rate, see, some reactions such as ionic reactions, they occur very fast. That is, precipitation of silver chloride occurs instantaneously by mixing of aqueous solutions. Okay, but some reactions are very slow. For example, rusting of iron in the presence of air and moisture. So, what this indicates? Some reactions are fast, some reactions are slow. So, rate of this reaction, meaning at which the rate of the reaction at which they are undergoing. Okay, so speed of the reaction or rate of the reaction can be defined as change in concentration of the reactant or product in unit time, meaning whenever you carry out the reaction, how much change you can see in the concentration of reactant or a concentration of product, that is a rate. So, to be specific, it can be expressed in terms of rate of decrease in concentration of any one of the reactants. That means if you carry out a reaction, then you use reactants to when they combine to give a product. So, reactants in reactant side, okay, if you consider reactant side, then there will be decrease. Okay, so if I consider here this reaction A plus B gives C. Okay, so what is the rate? Rate of decrease in concentration of any one of the reactant. That means this side, this concentration will decrease and product concentration will increase. Okay, when the reaction takes place. Okay. So rate of decrease in concentration of reactant and rate of increase in concentration of product, this is the rate. So consider a hypothetical reaction, that is reactant R gives product P. So 1 mole of reactant R produces 1 mole of the product P, meaning if you take 1 mole of reactant R, it will produce 1 mole of 1 mole of product P. So if R1 and P1 are the concentration of R and P respectively at T1, R2 and P2 and their concentration at T2, then delta T is equal to T2 minus T1. Delta T means change in the time is equal to final time minus initial. So delta R, that is concentration of the reactant, change in concentration of reactant is equal to concentration of the reactant at final minus concentration of the reactant at the initial. Then delta P, that means change in concentration of product. So that is the same, P2 minus P1, and square brackets represent the concentration. Now we will talk about reactant and product here, that is R and P. Now what is the rate of disappearance of R? Disappears means reactant is getting decreased. So rate of this decrease in R is given by decrease in the concentration of R divided by the time taken, meaning how much reactant is decreased, okay, and how much time is taken for that. So decrease in concentration of reactant by the time taken by it. So it is given by R by T. Okay. And second is rate of appearance of P, that is how much product is formed. So increase in concentration of product divided by time taken for it. So which is given by P by T. Okay. So we will see the equations properly above. Now see, these are the two graphs which shows the reactants and products change. Okay, so if you talk about reactant, the concentration is decreased. That's why you can see this curve here. And if you talk about product, the concentration is increased. So that's why the curve is going upwards. Okay, so based on this, we have units of rate of the reaction. So units, it is clear that units of rates are concentration by time. That means we know that rate of the reaction, okay, is basically what? It is a change in concentration of reactant, that is decrease or increase in the concentration of reactant or product by the time taken for it. So concentration is what? Concentration is uh, mole per liter. Concentration unit is mole per liter, and time unit, let us consider, is seconds. Okay, so the unit of rate will be, normal unit of rate will be mole per liter per second. Okay, so this is the unit of rate. Then next important thing, now let us apply the thing that we discussed already in one of the reactions. So here there is a reaction in which mercury and chlorine is treated to give mercury chloride. Okay, now here what you need to understand, that these two are the reactants. Silver, mercury and chloride are the reactants, and mercury chloride is the product. So how to write the rate of reaction over here? Rate of the reaction is given by decrease in concentration of mercury by T, which is also equal to decrease in concentration of chlorine by T, which is also equal to increase in concentration of mercury chloride by T. So this is the equation to show rate of reaction in terms of all the three species, that is 2 reactants and 1 product. So rate of disappearance of any reactants is same as rate of appearance of the product. That means the rate at which reactants are decreasing, or the disappearance of reactant take place, that will be always equal to rate of appearance of any product. Okay, if I consider this reaction 2HI plus H2 plus I2, then here also same thing. Now here what you need to understand, one more thing is added here, that is the coefficient. Here there is coefficient as 2, and here there are no coefficients, so we can consider it as 1. So whenever there is coefficient, you have to write the rate of reaction this way. The rate of the reaction is equal to, that 2 we have to take as reciprocal. So rate of the reaction is, now since it is decreasing, reactant side means decreasing, so minus 1 by 2 concentration of HI by T, okay, or I can write dHI by dt, which is also equal to, this is product, so it will be plus dH2 by dt, and this will be also equal to plus dI2 by dt. Okay, so this is given by the rate of the reaction. Okay, similarly for this reaction we will see 5Br minus plus BrO3 minus plus 6H plus gives 3Br2 plus 3H2. So rate will be given by, now since this is reactant, okay, 5 is the coefficient, so it will be 1 by 5. Since it is reactant, it will be minus sign. Okay, then d of Br by dt, which is also equal to, this is also a reactant which is having no coefficient, so we can write minus d BrO3 by dt, which is also equal to 6H plus, which is in the reactant side, so minus 1 by 6 dH by dt, and here this is the product side, so plus 1 by 3 d Br2 by dt, which is equal to, this is product side, so plus 1 by 3 dH2 by dt. That means d by dt is the what? It is basically the change that takes place. Okay, so this is the way to write the rate of the reaction, okay, whenever concentrations are given. Now let us discuss factors influencing the rate of reaction. Okay, now there are many factors which influence the rate of reaction. So a rate of reaction depends on experimental conditions such as concentration, then pressure, temperature, catalyst. Okay, so first let us discuss dependence of rate on the concentration. So rate of the chemical reaction at a given temperature, it depends on the concentration of one or more reactants and products. So the representation of rate of reaction in terms of concentration is called as rate law. Now here we will introduce one more term, that is rate law, and the equation of rate law is very important. Okay, so let us see rate expression and rate constant. Okay, so here consider a general reaction, A plus B gives C plus TD, where A, B, C, D are coefficients and of reactants and products. So rate expression for this reaction is given by rate is proportional to concentration of reactant A raised to the raised to raised to one variable, that is x, and concentration of B raised to y, other variable, where these exponents x and y may or may not be equal to the stoichiometric coefficient A and B, meaning this x and y is different from A and B. Okay, they may be equal but they are not the same. So rate is given by, now this is experimentally determined equation, so that's why the equation is this way. That means x and y we cannot theoretically determine. So x and y values already they will give through experimental method. So rate is equal to, according to this rate law equation, rate is equal to K concentration of A raised to x into concentration of B raised to y. So this we can also write as dr by dt is equal to K into concentration of A raised to x and B raised to y. That means here we only take the reactants, okay, we don't take the products here. So rate law is the expression in which reaction rate is given in terms of molar concentration of reactants, with each term raised to the some power which may or may not be the same as stoichiometric coefficient of the reacting species in a balanced chemical equation. Okay, so this is the statement for rate law equation. Now if I consider this reaction, 2NO plus O2 gives 2NO2. Okay, now experimentally determined order order of this reaction, or that exponent of the reaction is given by 2. Okay, so rate will be given by what? Now reactant is NO and O2, so it will be K into NO raised to 2, because here it's experimentally determined order, and O2 it is having not having any order. So this is the equation. So here equation experimental rate equation is given by this, in this manner. Okay, so some other examples are given below, that is chloroform when treated with chlorine gives carbon tetrachloride and HCl. So here rate will be given by K into rate into chloroform concentration into chlorine concentration raised to half. Okay, so rate law for any reaction cannot be predicted by merely looking at the balance equation, therefore theoretically, but must be determined experimentally. So that's why rate law is according to experimental procedure and not according to theory. Okay, so based on that we have one more term, that is order of a reaction, which is the exponents which we take in rate law expression. So rate is equal to K, A raised to x, B raised to y. This is a rate law expression. Now in this, like x and y which we take, the sum of that x and y is called as order of the reaction. So the sum of powers of the concentration of reactants in the rate law expression is called as order of that chemical reaction. Okay, so let us take this example here. Rate is equal to K into A raised to half and B raised to 3 by 2. So if I consider this equation, then order of reaction will be 1 by 2 plus 3 by 2, which is equal to 4 by 2, which gives 2 as the answer. So order of this particular reaction will be 2. So this is the way to calculate order of the reaction. Then the reactions taking place in one step, only one step reactions are called as elementary reactions, and when sequence of elementary reactions gives the products, the reactions are called as complex reactions. So let us start with the units of rate constant. For a general reaction, we have this equation, A plus B gives C D along with its coefficients. So rate is given by K, A raised to x, B raised to y, where x and y is n, which is the order of reaction. So K will be given by what? K is equal to rate divided by A raised to x, B raised to y. So we are finding the unit of rate constant, right? So that's why rate is equal to concentration upon time, that is mole per liter by second, and AX BY is equal to 1 by concentration raised to n. N is the order. So what we will get here when we apply this in every order reaction? So for zero order reaction, zero order means what? When this n goes 0. So for those reactions, the unit is mole per liter per second. Okay. Then when you have first order, okay, first order reaction, let us try to solve. If you don't understand, your K is given by concentration upon time. Concentration is what? Mole per liter by second into 1 by concentration, again mole per liter. Okay, now mole per liter raised to 0 means what? This whole term will go 1. Yeah, so this will, anything raised to 0 is 1, so this will go 1, and we will get only this equation, mole per liter per second. So that's why for 0 order we have this. For first order, this will be 1. Okay, 1 means what? We will get mole per liter, mole per liter. So this and this will get cancelled, so we will get second inverse for first order. And for second order, here there is you have to write 2. Okay, so this is square, so 1 will get cancelled with this and other will remain. So we can write this as liter per mole per second. So that's why second order unit is per mole liter per second or liter per mole per second. Next is molecularity of the reaction. Now what is this? The molecularity is number of reacting species taking part in an elementary reaction, meaning one step reaction. If you consider, then how many species are taking part in that? So that tells us the molecularity. Okay, which must collide simultaneously in order to bring about chemical reaction. It is called as molecularity of the reaction. So here NH4NO2 gives N2 plus H2O. So this is a bimolecular reaction having two molecules. Okay, so yeah, so here this is about molecularity of the reaction, meaning how many species are taking part. Then we will see about integrated rate equations, which are very important for your exam. Any one derivation will be asked from this. So zero order, first we will start with zero order reaction. So zero order reaction means the rate of the reaction is proportional to 0 power of the concentration according to experimental data. Okay, so if you consider a normal reaction, reactant gives product, then rate of that reaction will be what? Minus decrease in concentration of reactant with respect to time, that is minus dr by dt is equal to K into R naught. R naught is this, so any quantity raised to power 0 is unity, so rate is equal to minus dr by dt, which is also equal to, now this goes 1, so K into 1, so dr is equal to minus K into dt. Okay, so dr is this, dr I am taking this side, then dt, see dt and K will be multiplied together, so dr will remain one side, so negative sign will be that side. So when you apply integration both the sides, what will happen? This will get cancelled, derivative integration, and r will be remained here. Here also minus kt, so this d will go, so minus kt plus I is the integration constant. Then R naught is the initial concentration. So when at t is equal to 0, when time goes 0, concentration of reactant R goes R naught, R is equal to R naught, where R naught is the initial concentration of the reactant. Then we substitute this in equation, so we get R naught is equal to minus K into 0 plus I. So R naught is equal to I. So when you substitute the value of I in the equation, okay, what is the value of I? So I is equal to, see this, if I take I, if I keep I this side and take KT on the other side, then it will be KT minus R naught. Okay, so R will be equal to minus KT plus R naught, and when we compare the equation of a straight line, that is y plus mx, y is equal to mx plus c, if we plot R against t, we get a straight line this way. Okay, so with the slope minus k and intercept equal to R naught, so simplify the equation, we get K is equal to concentration of R naught minus concentration of R by T. So this is the equation for zero order reaction, which is very important. Graph along with equation and this derivation. Okay, everything is very important here. Then okay, zero order reactions are relatively uncommon but occur under special conditions. That means zero order reactions are rare, but whenever you apply some conditions, they will the reaction will take place. Okay, this is about zero order reaction. Then these are the example, like formation of the decomposition of ammonia. Ammonia decomposition is the example of zero order reaction, which you have to understand, because during exam they also ask about examples. Okay, so rate is equal to K, NH3 raised to 0, which is equal to K, because zero order means anything raised to 0 is 1. So K rate will be equal to K. Then again one more example is thermal decomposition of HI on gold surface, another example of zero order reaction. Okay, so this is about zero order reaction. Okay, so I will continue with the first order reactions in the next video. Okay, and we will solve problems also. Okay, thank you.